Because I sold the battery of my DIY e-bike, I needed a new one. But instead of just buying a new one, I decided to build my own. Since this is my first battery pack build, let's see if it will go up in flames. Before I started building the battery, I measured the capacity of each cell by charging and discharging them. I even recorded the charging and discharging process of each cell to see if there's anything wrong. Also, I measured the resistance of each cell. Then I've used this website for cell matching. I decided to make a 14S 3 parallel configuration. I'm using Molicel P42A batteries. In this configuration it will be a 52-volt battery with around 13 Ah. Theoretically it will be capable to pushing up to 7 kW. But since I use a COIC photon, I will just draw around 1 kW. So, let's start by printing the cell holder. That's how the printed cell holder looks like. The BMS will just sit on top, and the battery minus will be connected like this. Now I can start to push the cells into the holder. With that done, the battery looks like this. I cracked the holder here and there, but it is not critical because it won't influence the stability. I bought some pure nickel sheet metal and started by cutting it down to size. Since I own a lever share, it was easy for me to set it up and cut all the parts into the same size. Now I'm going to build the minus connector. I'm going to use a cable which was delivered with a BMS and a piece of pure nickel. I'm using a knife to slice it open to make it possible to solder. Then I make sure there are no loose strands and clean it up so it won't cause any problems later. So now I can solder it to the plate. I started by applying solder to the plate. Then I also applied solder to the cable. Then I was able to solder plate and cable together. The next step was applying Kapton tape to protect the cells against short circuits with the nickel plates. Then I used a knife to cut off the isolation on the minus pole of the cells to have a bigger area for the spot welds. Just another quick check if everything will fit before I start with spot welding. I'm going to use this CC spot welder. I started by spot welding each cell. And then I measured if the voltage of each cell is still good with my multimeter. All voltages are looking good, so I proceed to go on with the spot welding. I'm using 4 spots per cell here. I think maybe 6 will be better. What are your opinions? Write it down in the comments. I spot welded all nickel plates, always switching from side to side to make sure I don't make a mistake. After I finished spot welding, I also measured the voltage of each pack with my multimeter to check if there went anything wrong. Then I cut down another nickel plate for the positive output of the battery. So again, I applied soldering to the cable and to the plate and soldered them together. Next step was to spot weld it to the cells. This time I'm using 6 spots. After spot welding it, I've noticed an issue, because unfortunately the solder wicked up the wire and now it is very stiff, but I need to bend it down. So I cut it open and used my soldering iron to bend it down. Because I had to apply a lot of heat to the cells, I rechecked if the cells are still okay. Everything was still okay, so I proceed to go on. The open end of the cable needs to be isolated again. So I had to remove the fuse, which I've added to have some more protection against short circuits, and pushed shrinking tube onto the cable. I shrinked it down using my heat gun. Next big step was to connect all the sensor wires of the BMS. I've made a plan here so I don't make a mistake, because it's a very critical step of the building process. I started by soldering the first cable to the minus pole of the battery. Then I switched to the other side so I wouldn't mix up the order of the wires. I always tried to heat the solder just as much as needed to don't damage the cells. Also, I soldered the sensor wire into the middle of the plate so I don't have to apply the heat directly above the cell. Maybe a tap on the nickel plate would make more sense so that I can solder the sensor cable to it. How are you solving this problem? Write it down in the comments. So, I finally soldered every sensor cable to the battery. So now the battery looks like this. Now I'm going to secure the positive lead with cable ties as well as the fuse holder. I had to bend the connection in the fuse box by 90 degrees, so I had to make a cutout into the housing. With everything properly secured, I'm going to use liquid tape to isolate and protect everything. Then for further protection and isolation, I added Kapton tape. The finished side looks like this now. Unfortunately, I forgot to add the Bluetooth dongle and the temperature sensors. The BMS comes with two sensors. I want to use one to measure the temperature underneath the BMS, and the second one to measure the temperature in the middle of the pack. For that, I had to poke a hole into the Kapton tape again. I'm making sure here to find the middle and poke a hole using a screwdriver. Then I'm pushing in the temperature sensor from the top into the hole which I've made. Then I'm using these thermal pads from Arctic to have a better heat transfer from the cells to the sensor. At first, I'm pushing in some of the thermal pad into the hole and making sure it will touch every cell. Then I push in the sensor and after that another layer of thermal pad. I'm pushing in some thermal pad underneath the BMS and making sure it will touch the BMS and also the cells underneath. Then I will push in the thermal sensor into the hole I've made and plug it with another layer of thermal pad. After that, I make sure to cover the other side with Kapton tape too. Then I'm adding fabric to the side of the battery as a protection. Next thing I need to add is a charging connector. I'm using a round connector here with some crimp contacts. One side of the charging port will be connected directly to the screw terminal of the BMS. The other side will be added to the fuse holder. Because I wanted the fuse box to be easier accessible after heat shrinking the battery, I had to remove it again. Then I added the first layer of heat shrink tube. And made a small cutout for the positive cable. Then I used my heat gun to shrink the tube. Once the battery is fully insulated with heat shrink tubing, the fuse can be reinstalled. Now I can also add the charging port to the output terminal. And then secure everything with a zip tie. Next thing to do is to add the XT90 battery connector. Since the cables are pretty thick, I'm using a high power soldering iron. Then I added another layer of heat shrink tube to protect the battery even further against moisture. To close the open end of the heat shrink tubing, I folded the end together and then used a narrow strip of heat shrink tubing to hold it in place. If you know a better way to make this type of battery waterproof, please let me know in the comments down below. I've used a little bit too much heat here and burnt a hole inside the tube. To cover it up for now, I'm going to use duct tape. And yes, that's what the finished battery looks like. Not the prettiest one, but I guess for my first try it's okay. On the areas where the battery will later touch the frame, I also applied felt. And that's what the battery looks like inside the frame of my Molicel Supreme downhill bike. The cable wraps around the frame super good. And I can finally turn on the bike again. If you enjoyed this video, go ahead and give it a thumbs up. And if you want to catch more of my projects and never miss a video, hit that subscribe button. See you next time.